Welcome to this explainer. Today, we're taking a slightly different, kinda cinematic journey into the evolution of autonomous AI agents. More specifically, we're looking at the highly specialized habitats they actually need to thrive safely. We're talking about a breakthrough technology built to contain this entirely new species of digital intelligence. So let's just jump right into the big, critical challenge here. How on earth do you safely contain an evolving AI agent? I mean, think about it. When you've got an AI writing, testing, and executing code completely on the fly, its behavior is, well, fundamentally unpredictable. Running that wild AI-generated code natively on your own servers? Yeah, that's a massive security risk. It could crash your mission-critical systems, eat up insane amounts of compute, or, worst case, expose your private infrastructure to outside threats. So how do we give these rapidly evolving agents the dynamic sandbox they desperately need to learn and run without unleashing total chaos on our own underlying systems? Well, the source material introduces us to the perfect answer: AgentENV. You can basically think of AgentENV as the ultimate containment facility. It's a self-hosted sandbox runtime designed specifically for these kinds of next-gen software workloads. Whether you're running autonomous coding agents building entire apps, sophisticated code interpreters crunching data, or complex tool use workflows navigating the web, this system gives you a pristine, perfectly cached Linux environment for every single isolated task. It completely shields your main infrastructure while letting the AI safely explore inside its own little bubble. All right, moving on to Section 1. Enter the AgentENV Sandbox, built for scale and extreme speed. Check out this number, 50. What does that actually mean? It means snapshot-backed environments in AgentENV can boot up or resume in under 50 milliseconds. That is literally a fraction of the blink of an eye. When you're operating at enterprise scale, that velocity is absolutely everything. It means environments that aren't being used can instantly release CPU and memory back to your host system, go completely dormant, and then snap right back to life the exact microsecond your agent gets new work. And it gets better. It takes under 100 milliseconds to pause an environment. In that tiny, microscopic window of time, AgentENV incrementally snapshots the agent's memory and file system changes. It effectively freezes it in time, even if there's some incredibly heavy disk modification going on. Preserving efficiency like this at scale, it translates to massive cost savings. When you're juggling thousands of autonomous agents at once, these lightning-fast pauses and resumes are the difference between a highly profitable operation and a totally bankrupting one. Okay, Section 2. Inside Firecracker MicroVMs, the architectural deep dive. So, if we look deep inside AgentENV, every single sandbox is powered by a Firecracker MicroVM. Now, a Firecracker MicroVM is essentially a highly secure, completely private Linux kernel spun up for every single sandbox. We aren't just talking about a standard software container here. No, this provides true, impenetrable, hardware-level isolation. Your AI agent can dream up and execute whatever unpredictable code it wants safely inside this micro-VM because it is physically walled off from the host machine and securely separated from any other agents next door. Let's trace a single command through this setup. First, a client sends a request to the API, which is handled here by Axum. Then the orchestrator steps in. This is kind of the brain of the operation, managing the complex lifecycle state machine, deciding whether to create, pause, or resume an agent. From there, the Firecracker VM spins up to provide that strict hardware-level isolation we just talked about. And finally, execution hits the block device layer, efficiently handling layered storage and memory via OverlayBD and Ublk. It is basically a beautifully orchestrated assembly line engineered for secure AI execution. Section 3. Snapshots, templates, and time. Manipulating the agent lifecycle. So, how do they manipulate time to get those lightning-fast restores? AgentENV relies on a really powerful combo: OverlayBD and Ublk. Basically, this is a layered block device and user space block driver combination that gives us copy-on-write image sharing. To put it simply, it lets multiple sandboxes share the host system's page cache and read-only base layers. If you've got 10,000 agents running the exact same base OS, you only store that operating system once on your disk. This absolutely skyrockets your server density and unlocks the magic behind those blazing fast memory restores. Thanks to that underlying architecture, when you start an agent, you've got two distinct choices. Option 1 is a warm start. This restores a known file system state from a literal cryogenic snapshot in milliseconds. The agent wakes up, full memory intact, and just picks up right where it left off. Option 2 is a cold start. This process pulls a fresh external OCI image, say Ubuntu 24.04, directly from a registry and dynamically converts it into a workable block device right at runtime. This gives your agent a completely fresh, blank slate habitat to work in.
Now, here is a truly awe-inspiring capability built into the system: forking. Imagine your AI agent reaches a tricky decision point and needs to test a bunch of complex solutions simultaneously to find the best path. Well, AgentENV lets you literally clone the habitat, the file system, the memory, the configuration, the whole shebang, into up to 16 independent parallel realities on the exact same node. The source sandbox pauses for just a split second to capture its state, and then all those children wake up and start exploring their own parallel workflows. For autonomous agent testing, yeah, that is an absolute game changer.
Moving right along to Section 4, scaling the sandbox, the distributed control plane. To run a massive production environment, AgentENV uses this really elegant distributed multi-node architecture. Client traffic flows into the system through the gateway at port 8080, which acts as your reverse proxy. Then, the scheduler at port 9090 operates as the central nervous system, making the big decisions on node selection and seamlessly binding the sandboxes. Finally, the runtime nodes over on port 8000 do all the heavy lifting, actually running those isolated Firecracker sandboxes. This distributed control plane guarantees that as your AI workforce grows, your agents scale completely effortlessly across your fleet.
Now, here is why this is such a big deal for developers: E2B API compatibility. AgentENV exposes an E2B compatible HTTP API. What does that actually mean? It means you don't have to rewrite your applications. If your team is already using the E2B SDK or command line interfaces for your AI agents, your existing codebase will just seamlessly integrate with this self-hosted AgentENV straight out of the box. You get all the massive benefits of private hyperfast containment without changing a single line of your code. How cool is that? So, as we wrap up this explainer, we've really seen a cinematic evolution in how software is contained and executed. We've explored exactly how self-hosted sandbox environments provide the extreme speed, unmatched scale, and uncompromising hardware-level isolation that we absolutely need to safely develop the next generation of AI. So I'll leave you with this one final thought to chew on. Now that the ultimate containment facility for AI agents is a reality, what groundbreaking systems are you going to unleash inside it?